All right, today you're going to start the lessons on inequalities. Right before the Christmas break, we finished up expressions, and then we moved into the equations. Now we're moving into the next phase, which is inequalities. And this will kind of end the things we're working on that deal with algebra before we get into geometry. So most of you have dealt with inequalities in the past. You should have, greater than, less than. Those are called inequalities. The word inequality means not equal, okay? This is going to cover digits 9, 1, 9, 2. It's actually going to cover several different things with digits. But right here it just has for 9, 1 and 9, 2. So first thing we're going to deal with is solving inequalities. Our essential question for today for this lesson is, how is solving an inequality similar to solving an equation? So if you will make sure that you have these things copied down in your notes, so I'm going to go back. The title of what we're working on is dealing with inequalities. What we're going to focus on is solving equations, and our essential question is, how is solving an inequality similar to solving an equation? Don't need to remind you to copy down the important things. I'm going to go ahead and copy this down or highlight this, but you don't need me to tell you what you need to highlight, okay? Before we get started, let's do a quick review on equations. Remember, we work with one-step equations and two-step equations. Our goal is to solve for the variable, and solving equations is going to be the same thing that we do to solve an inequality, but instead of having an equal sign, it's going to have a greater than or less than sign, or greater than or equal to sign, or less than or equal to sign. So if we have this equation right here, we know that 3 plus 3n equals 15. I don't want you doing guess and check. I want you actually working through the problem. We know that we want to work through and get rid of addition and subtraction first. We want to do multiplication and division last. And then obviously we want to check our work. So our goal is to isolate the variable. We have an n right here. So what I want to do is get rid of this positive 3. So I got to subtract 3. And just like we talked about before the break, if I do something one side, I've got to do the same thing to the other side. So I subtract 3 from this side. 3 minus 3 is 0. That cancels out. So I'm going to drop down that 3n. So I bring the 3n straight down. 15 minus 3 on the right side of the equal sign is 12. So that now gives me 3n equals 12. So I've taken care of the first step. I've gotten rid of the addition or subtraction that's in the problem. Now I'm going to go to the second step to see if there's any multiplication or division. I have 3n. 3n is multiplication. So the inverse of multiplication is division. So I always divide by the number that's with the variable. So the variable is n, the number with it is 3. So I divide each side by 3. And when we multiply or divide, we want to cancel out. 3 divided by 3 cancels each other out. So when I divide that, that gives the variable n. And then 12 divided by 3 gives you an answer of 4. And now I've taken care of the second step. Now the last step is to check my work. So what I'm going to do is take this 4 and I'm going to substitute it in for that n up here. So that means 3 times 4. 3 times 4 is 12. 12 plus this 3 equals 15. So that does prove that I've worked that problem out correctly. All right, let's go to the other side. I'm going to rewrite this x over 2. So instead of saying x divided by 2 the way it's written in the problem, I'm going to just write it as x over 2. So x over 2, which means division, x divided by 2 minus 5 equals 13. I'm going to go through the same steps. I have addition and subtraction, so I have a minus 5. The inverse of a minus or negative 5 is a plus 5 or positive 5. So I always have to use the inverse operations. Sorry about the bell. If I add 5 to the left side, I have to do the same thing to the other side. So I'm going to add 5 to this side of the equation. So a negative 5 and a positive 5 cancel each other out. They're opposites. So when I drop down that x over 2, so that gives me now x over 2 equals 13 plus 5 gives you 18. So I've taken care of the first step. I go to the next step, look to see if I have any multiplication or division. X over 2, that means division, that line right there. So the opposite or inverse of division is multiplication. So again, I multiply or divide by the number with the variable. So I multiply by the 2 on both sides. These 2 cancel out. So that leaves x equals 18 times 2 gives you 36. All right, so I took care of the second step. I can check my work now. 36 divided by 2 is 18 if I substitute that 36 for x. 18 minus 5 is 13, so that proves to me that we solved the problem or the equation successfully. All right, so let's move on to what this is about. Or actually, let me let you work these two problems. So if you will work these two problems, please. And so I'll underline these. And if you'll notice this second one right here, that has the distributive property, so you're going to have to distribute that 4 times the minus x, and then you're going to have to multiply the 4 times that positive 4. So don't forget to use the distributive property there. All right, so now let's get into our notes. And again, stop the video, pause it as you need to. All right, we're going to start off with what are inequalities. So what is an inequality? And again, I need you copying this down. An inequality is a mathematical sentence that uses the less than, greater than, less than equal to, or greater than equal to symbol to compare the value of two expressions. Now, this is going to work the same way as we did equations. The only difference, instead of having an equal sign, we're going to have an inequality symbol. So what is the solution to an inequality? The solution to an inequality is also called the solution set. You do need to know what that phrase means, solution set. There's not necessarily going to be one set answer as the problems we just worked that were equations. Instead, you may have a solution that represents a group of numbers or a bunch of numbers. That is called a solution set. A solution set is any value of the variable that makes the inequality true. And the way we're going to represent this is with the use of a number line, and we're going to call that, in this case, possibly a graph. All right, how do we solve inequalities? Solving an inequality is going to be solved the same way we solved the equations. So we're going to use inverse operations that we use to solve two-step equations. We're going to apply that to these inequalities. Remember the work backward strategy. We're going to do the inverse of the order of operations. So what that means is what we just did, we're going to take care of our addition and subtraction first, and then we're going to worry about our multiplication and division last. So far, not really anything is new other than the fact that we talked about what an inequality is, less than, greater than, less than, equal to, greater than, equal to, and how we're going to solve these inequalities. We're going to do the same steps as we use equations, adding and subtracting first, then multiplication and division second. All right, now how do we go about solving these inequalities? We're going to use the same process or steps as we did with solving two-step equations. The only difference is if we multiply or divide by a negative number, we have to flip the inequality sign to point the other direction. This is extremely important. If you do not do this or copy this part down so that you can refer back to it, you will have a lot of missed problems. So this is extremely important here. So if you multiply or divide by a negative number, we're going to flip the inequality symbol. You have to remember to do that as you're working through these problems. All right, let's do this first example here. This is a one-step inequality. Now, if I gave you this problem like this, and I wrote it as x plus 5 equals 7, we know that we would subtract 5 from both sides. We get rid of that plus 5, so I subtract 5 here. And I would subtract 5 there by doing the same thing on both sides. And we would know that cancels out, so that leaves x equals 2. The only difference between this problem here and this problem over here is the fact that it has an inequality symbol. It has a greater than symbol. So we're going to work this the same exact way. We have x plus 5 is greater than 7. We're going to take care of our addition and subtraction first, multiplication and division second, and then obviously we can check our work. Now, the way this works is the same exact way as the equations. We have a plus 5 or a positive 5, so that means we have to do the inverse or opposite of it. So we're going to subtract 5. In order to balance it out, we've had to do the same thing to the other side of the inequality equation, or what's called the inequality. 5 minus 5, that cancels out. I drop down the x, and then 7 minus 5 right here is 2. Instead of bringing down an equal sign, I'm going to drop down that greater than sign. So our solution is any number that is greater than 2. So our solution set is a number that's greater than 2. All right, how can we check our work? We're going to check the work the same way. We're going to take this number and we're going to substitute it back in. So if I plug in a 2 there, substitute it in, 2 plus 5 is 7. Is 7 greater than 7? No. But what we have to realize is this says x is greater than 2. So would I substitute a 2 in? No. So a number we would maybe substitute in would be a number greater than 2, such as 4. So if I substitute a 4 in, 4 plus 5, does 4 plus 5 equal a number greater than 7? 4 plus 5 is 9. Is 9 greater than 7? Yes, it is. So that works out. All right. Now this is a two-step inequality. Again, take care of multiplying and adding and subtracting first, and then multiplying and dividing second. Then we check our work. And again, it works the same exact way. So what I'm going to do, here's my variable on the left-hand side. So I've got to get rid of this 4 first. So I'm going to do minus 4 since that's a plus or positive 4. Balance it out by doing the same thing over here. Positive 4 and negative 4 cancel out. So I drop down the 3x. I drop down the greater than sign. 13 minus 4 is 9. I've taken care of my addition and subtraction. I now move to my multiplication and division. I have multiplication here, so the inverse is division, so I divide each side by the same number. I divide by the 3 because it's with the x, the variable, and when I do that, the 2 3's right here cancel out, so I bring the x down, bring down the greater than sign, and 9 divided by 3 is 3. So my answer to this inequality is any number that is greater than 3. Now, when I check my work, I'm not going to use 3 because I've got to use a number greater than 3. So a number greater than 3 could be like 5. So if I substitute a 5 here, 3 times 5 we know is 15. Is 15 plus 4 greater than 13? 15 plus 4 is 19. So 19 is greater than 13. So that proves to us that x is any value greater than 3. All right, we have another one here. I want you to try this one though. So I'm going to highlight this one for you to do. I'm going to type here, on your own. All right. What I am going to do is go ahead and give you the answer just to make sure that you're working at it or working it the right way. So if you were to work this on your own, you would get, and make sure I'm doing it the right way, you would get x is actually less than negative 4. And what I want you to do is try to figure out why it is x less than negative 4. And please ask questions as you work. If you have any questions, pause the video, raise your hand, I'll be glad to come to you. All right, so let's stop this video and then we'll pick up the next part of the lesson on the second video.